Okay, I want to make a short video just explaining the formal definition of the language generated by a machine. There's a little bit of notation that I think is kind of neat, and it takes that idea of the transition function and extends it a little bit and makes it kind of recursive. Essentially, first of all, the definition is just a string W. I'm using W for word, right? Like a word over an alphabet. A string W is recognized or accepted by a machine M if that string, input string, takes the starting state S0 to a final state. This is what I said in the previous video, right? Like if the state you end on is a quote final or accepting state, then it accepts that input string. So in order to rigorously describe that, okay, we have to take this transition function, which normally takes an input state and input character, and then gives us a output state. We have to extend that to give us, instead of an input character, just like an input string, an entire string. Okay, so this, remember that I is the set of inputs, I is the input alphabet. So the elements of I are just characters, but if we want to talk about strings over that alphabet, then we want to talk about I star. I star is the set of all strings. So now we're considering our second input to be an entire string, not just a single character. And in order to define what that means, we can use this recursive definition. First of all, if that string is the empty string, lambda, then that means you don't receive any inputs, so you stay at whatever state you started at. So the transition function would be defined like this. F of some state and give lambda is going to be equal to whatever state you started at. And that's for any state in the set of states that you happen to be starting at, whether it's state 0 or state 1 or 2 or whatever. And then there's this recursive part where we say, okay, if you already have a word W and then a character A, right? So the W is a word, the A is a character, okay? Over here, we're going to say this is S is a state, W is a word because it's an element of I star, and A is a single character element of I. This is essentially like you already have a word, and then we're appending to the end of that word one extra character. We're going to define this to be the result of the transition function that you get by taking f of SW, so that's take the word and get to whatever state that arrives at after the sequence of characters in W, and then take that ending state and use that as the input for the next step, which is f of that state and then input A. So this recursive structure essentially, remember that f outputs a state, right? So that becomes a valid input for the first slot in f, right? So we're composing the function with itself here. This is classic recursion here. So just as an example, say you start at S0 and you receive the input ABC, right? Then what we'd say is take this entire word except for the last character. So we're going to take AB as our W and then C as like our last character there. And recurse. This is f of S0 AB and then C. And then you can recurse again because this is still a character string of length 2. You can do f of, and then we'll do f of S0A, and then with B, and then take that output and take that with C. Whew! And it starts to get kind of messy, but the idea is you're recursing all the way down. And then you could do this one more step where you go all the way down to the base case, which is lambda, and then go from there. Okay, so this is an extended version of the transition function, allowing us to basically have a notation to talk about what it means to input an entire string to a machine instead of just a single character from I. So then you can say the language generated by M is, L of M is going to be set of all words W in I star, so that's all strings over the input alphabet, such that f of S0W Okay, so this is starting at the starting state and giving it the string W, right? This is gonna produce an output state, and that state needs to be an element of our set of final states, right? If it is, then that word is in this language generated by M. So there we go. This video is just to explain that notation and explain, this definition, because I thought it was a bit of a tricky one to wrap your head around. So I hope that helps.